Okay, so topic 4 is titled Additional Applications for the Addition Property of Equality. So the first thing I want to look at is taking equations that are not just a single step, but that have to be simplified first before we can then apply the addition property of equality. And in case you forgot, the addition property of equality is the property that allows us to add or subtract things from both sides of the equation. Okay, so we're going to have to do a little work first, and then we can apply the addition property of equality. And this is very typical. In a normal equation, we're going to get equations that have lots and lots and lots of steps. And the first thing we do is we try to simplify each side as much as we can before we start applying properties. So for this first example, we want to look at the left-hand side separate from the right-hand side, and we want to simplify each of those independently. So we want to look to see, do we have any like terms? If we have like terms, we want to combine them. So looking at the left, I have 3x minus 2x. Those would be considered like terms. So I want to go ahead and combine them. I just add or subtract the coefficients and keep the x. So 3x minus 2x is just 1x. So I write that as, instead of writing the 1, we just write a single x. So I get x plus 5 equals 5 minus 2, which we know to just be 3. This is now something that we can do. We've already practiced stuff like this, where we just have the single x and we need to isolate it by applying the addition property of equality. So my issue is, with this x, I've added 5 to it. I want to undo that. How do I undo addition? Well, I subtract. So I want to subtract 5 from the left. But to maintain the balance that's inherent to an equality or an equation, we need to subtract that 5 from the right as well. You have to add or subtract whatever from both sides of the equation to maintain that balance. So I'm going to subtract 5 from both sides. Over here on the left, we have 5 minus 5. Well, 5 minus 5 we know to just be 0. X plus 0 is just x. So we can say those 5s have canceled. They've canceled because they equal 0, leaving that x alone. All right. Now on the right-hand side, I want you all to get to the point where you can just say 3 minus 5 is negative 2. But in case you're still a little rusty, remember 3 minus 5 can be written as addition. And if you can rewrite subtraction as addition, you only have to remember the rules for addition. So 3, instead of subtracting positive 5, we're going to add negative 5. And then if you're adding two numbers with different signs, you subtract their absolute values and then just keep the larger sign. So 5 minus 3 is 2, but we have to determine, is it positive 2 or is it negative 2? Well, I have 5 negatives, but I only have 3 positives. So that means I have more negative than I do positive. So this is going to be negative 2. And then for this example here, for parts A and B, we're going to check the solution. So let's check x equals negative 2 against the original equation. So for that original equation, anywhere I see an x, I'm going to replace it with a negative 2. So I get 3 times negative 2 minus 2 times negative 2 plus 5 equals 5 minus 2. All right, and we want to see if replacing the x with negative 2 really does give us a true statement. So 3 times negative 2, we're multiplying two numbers with different signs. That just equals negative 6. Minus 2 times negative 2, I'm going to treat the minus 2 like a negative. So negative 2 times negative 2 is positive 4. So I'm going to bring that down as plus 4. And then I'm going to drop down my plus 5. And then 5 minus 2 we know is 3. Okay? So now negative 6 plus 4 plus 5. Let's go ahead and look at the 4 and the 5 since they're both positive. 4 plus 5 is just 9. So I get negative 6 plus 9 equals 3. Well, negative 6 plus 9, I'm adding two numbers with different signs. So again, I subtract the absolute values. 9 minus 6 is 3. And then I have to ask myself, is this 3 on the left positive or is it negative? Well, I had 9 positives, only 6 negatives. So that means I had more positive than negative. So this 3 remains positive. 3 does equal 3. So we can say with confidence that the solution is negative 2. All right, for part B, this one's a little different. We have to distribute for part B. So remember, the distributive property allows you to distribute through addition or subtraction. So this 6 that's on the outside, I want to multiply it by the 3x, and then I want to multiply it again by the 1. Okay, so to multiply 6 and 3x, I just multiply 6 and 3, which is 18, and then I keep the x. And then 6 times 1 is just 6, and that equals 19x. So we've simplified both sides of this equation the best we can. What's a little bit different here is I have x's on two sides of the equation. And in the previous examples, before we applied the addition property of equality, we had x on just one side of the equation. Well, let's see if the addition property of equality works to move variables as well. It should. This 18x is kind of like adding 18x to the 6. So this is addition of 18x. The way I undo addition is by subtracting. So I want to subtract 18x from both sides of the equation. On the left, 18x minus 18x, that's just 0. There's nothing left. So 0 plus 6 is just 6. And then on the right, 19x minus 18x is just 1x, or just a single x. So we have 6 equals x, but we want to write it the opposite way. We always want to put the variable first. So we have that x equals 6. Okay, so let's go ahead and check our work. We're going to check x equals 6 against the original equation. So anytime I see an x, I'm going to replace it with a 6. So I have 6 times parentheses, 3 times 6 plus 1 equals 19 times 6. On the left, I'm going to simplify what's inside parentheses first. So inside parentheses, I have 3 times 6, which is 18. And then I have a plus 1, so that's 19. So I have 6 times 19 equals 19 times 6. And at this point in time, we can see that this solution works. 6 times 19 really does equal 19 times 6. That's the commutative property of multiplication. The commutative property of multiplication just says you can change the order of the things you're multiplying. The result is going to be the same. And we can prove it. We can take 19 times 6. Well, 6 times 9 is 54, so I want to keep a 4 and carry a 5. 6 times 1 is 6, plus 5 is, let's see, 11. So we get 19 times 6 is going to be 114. If I take 6 times 19, it's still going to be 114. So we can see here the left really does equal the right. And we can say with confidence that x equals 6. Okay, so that's taking just a slightly more complicated equation, simplifying it to where we can then apply the addition property of 0. Okay, so just be on the lookout for that stuff soon because we're going to practice much more complicated equations. Last up, we have example 5, which says write the equation using x to represent the unknown. So there's going to be some unknown value in here, and we're going to use x to represent that. And then once we get an equation, we're going to solve. So I do want to remind you there's something in math called direct translation. We're going to see much more with direct translation in future sections, but just in short, direct translation is the process of converting words to math. Okay, that's a very informal definition, but we're going to talk in depth about converting words to math. But here we're just going to do really simple practice, okay, to kind of get your brain thinking direct translation. So for part A, it says if 12 is subtracted from a number, the result is -2. So we want to take a number. We don't know what the number is. The directions tell us to use x. We want to take some number, and we want to subtract 12 from that because it says if 12 is subtracted from a number, so x minus 12, the result is, that's our equals, the result is -2. So if x is subtracted from a number, the result is -2. Find the number. We're just taking x minus 12 as -2 and solving it. So I've got my x alone. The issue is 12 has been subtracted from x. How do we undo subtraction? With addition. So I'm going to add 12 to the left, but if I want to maintain balance, I have to add 12 to the right as well. So on the left, -12 plus 12 is just 0. X minus 0 is just x. And then on the right, we have -12 or -2 plus 12. So again, get to the point where you can just see what this answer is going to be. But for now, we're going to kind of practice some of that by hand, those reminding ourselves how to do those steps by hand. So when we're adding two numbers with different signs, we subtract the absolute value. So 12 minus 2 is 10. But then we have to ask ourselves, is it positive or is it negative? I have 12 positives, but only 2 negatives. That means all of the leftovers have to also be positive. So we would say here x equals 10. And for these two, we won't check our solution. I think we've gotten a good bit of practice with that. Now, part B is a little bit different. A lot of times when you see the word of in math, it can indicate multiplication. Now, that doesn't mean every time you see the word of, it means multiply, but oftentimes it will indicate that you should multiply. So for this one, we have the difference. That just means subtract. So the difference between 2/5 of a number, so we're taking 2/5 of a number. That means 2/5 times some unknown number. We're going to call it x. And we want the difference between that and 8. Well, that just means take 2/5 of a number, x, and then subtract 8. And then it says is, that's our equals, is 7/5 of that number. So they're saying take that same number and multiply it by 7/5, and that's going to be the other part of this equation. Okay? So we have the difference between 2/5 of a number and 8. So 2/5 x minus 8 equals 7/5 x. We want to solve this. So this is very similar to part B in the previous example. We've got x's on two sides of the equation. We want x's on exactly one side of the equation. So what could we do? Well, I have more x's on the right than the left. So I'm going to go ahead and move my 2/5 x to the right. And if you think about it, 2/5 x is positive, so that's like adding 2/5 x to -8. So to undo that, I want to subtract 2/5 x. Well, 2/5 minus 2/5 is just 0. So 2/5 x minus 2/5 x is just 0. 0 minus 8 is -8. And then if I have 7/5 x minus 2/5 x, that's really just 7/5 minus 2/5. Well, 7 minus 2 is 5. And 5 over 5 is really just 1. So even though it looks crazy, 7/5 x minus 2/5 x is just x. So we always want to put the x first. We would say x equals -8. So we can say with confidence here the solution is -8. If you want to go back and check the solution for both of these, you're welcome to, but for the sake of time in this video, I'm just going to skip it. Okay, so kind of start wrapping your head around this idea of converting words to math. We're going to do a lot of it later in this chapter. And also understand that sometimes before you can apply the property, you have to do some simplifying to your equation first. Okay, and that's going to be a big theme in future sections. All right.